All right, 3.4 for grade 11 is just properties of exponential functions. So we're going to talk about domain, range, intercepts, how to create a table of values, and graph an exponential function. So an exponential function is just anything to an exponent of x. It could be an integer, it could be a fraction, it could have an a value, and we'll get into those transformations in the next section. But the easiest way to graph this right now is to create a table of values. So this says graph this function. This is 4 times half to the x. So I'm going to create a table of values. Okay, use my skills with table of values and select good numbers to plug in here. So for sure I'm going to plug in 0. Right? If I plug in 0, this is going to be 1. 4 times 1 is 4. This is a good number I know I'm going to have. And this is the y-intercept. Okay, I know that for sure that this is going through 4 over here. Okay, now I can plug in 1 for sure. I can plug in 2, 1, 2. But I also want to plug in negative numbers, because if I plug in a negative numbers, if you remember the negative exponent lesson or rational exponent lessons, I did a recall, it'll flip this 1 over 2. So if I put a negative 1 there, this now becomes a 2, and 4 times 2 is 8. Okay, or you can plug it into your calculator, wherever the case may be. But I'm plugging in a negative 1 and a negative 2. So negative 1 becomes 8, and a negative 2 is really 2 to the 2, which is 4. 4 times 4 is 16. Okay, if I plug in a 1, it's 4 times a half, 2. Okay, and if I plug in a 2, it's 4 times a quarter, 1. And if I keep going with this table of values, I'm going to keep getting smaller numbers, because I'm increasing the multiples of a fraction that is less than 1. So I'm going to get smaller number, smaller number, smaller number perpetually. Okay, so how does this look if we graph it? First of all, let's talk about domain. The domain in exponential functions is x is an element of all real numbers. There's no limit to what I can plug into that x. I can plug in negative a million, 1 over 4, negative 0.00646. Doesn't matter. Anything can be plugged into the x. Therefore, XER. Okay, the range, on the other hand, is YER, but there's some things that we can't plug in, there's some things that we plug into X that won't give us a particular result for Y, and I'll leave that until we graph it so we can see it a little easier. Now let's plot these points now. Okay, so at negative 1 we go up to 8, and at 2 we go up to 16. Okay, so it's kind of like opposite exponential growth this way. Okay, and this is falling. It's actually half-life right here. All right, I'm multiplying by half, and I'm going to keep multiplying by half forever. What I know about multiplying by a half forever is that no matter how small the number is going to become, I know for sure I'm not reaching 0. Okay, so this tells me that y must be greater than 0. There's no way that this line is going to touch 0. If I find half forever, even if I do it 1 zillion times, 1 zillion halves times 4 is still greater than 0. Okay, so I have an asymptote right at y equals 0. So my asymptote, I'll do it in a different color. My asymptote is actually y equals 0. There's a dotted line right at 0 that the function can never touch. Exponential functions always have a horizontal asymptote at some value of y every single time, whether it's at 0, it could be plus, it could be minus, there's always one horizontal asymptote. Okay, so look out for that. Now this function can be here or it can be flipped underneath the asymptote. Both work. When is it going to be flipped underneath? Well, we remember transformations of functions. If I have a negative sign in here, it means I'm going to flip it on the x-axis. Okay, so next, intercepts. Let me just underline these in the appropriate color. Okay, we did domain and range. Intercepts are pretty easy. Since I know that it has to be greater than 0, I know there are no x-intercepts. And the y-intercept is really easy. I mean, just plug in 0 into the function. 0, well, half to the 0 is 1 times 4. The y-intercept is, if I plug in 0 into x, I get 0, 4. Okay, give it as a point. This is max Intervals of increase and decrease, we want to find out when the function is increasing and when is it decreasing. And when we consider this, we always look from left to right. So visually, we just look at this function and we know that it's decreasing from left to right, no matter where. If I'm over here, if I'm over here, this is always decreasing. So I can say no interval of increase, and I can say it's decreasing when x is an element of all real numbers. This means that for every single x value, every single real number of x, negative infinity, 4, 6, plus 1,000,006, 0.04, every single value, this function is decreasing from left to right. Okay, and the last thing I want to talk about when we're discussing exponential functions is, let's say you have a table of values and you want to come up with an equation. It's not like first differences, but it's kind of similar. We want to see what is it doing from point to point. What's happening here, right? So here I'm just multiplying by a half. I'm multiplying by a half. How do I get from 4 to 2? I multiply by a half. And this is true for all these y values to get to the next step. So this really helps find what my base is in my exponential function. Okay? It doesn't really help me find this value. You want to find this value, just look at where it's 0, right? Because everything to the 0 is 1. So you're always going to be left with the a value. So if I want to find my a value, which is in front of the exponential function, I look here where x is 0. Okay, I guess it's technically my y-intercept. And if I want to find the b value, I want to see what's happening to the y's. And when I say b value, an exponential function always takes this form. So it's a times b to the x. Okay, we call this the base. And this is just the multiple, like the a value, like that 4.